we can't. We can't really hear that.
What? Hear what?
Your soundboard effects.
No, I
You
don't.
started it.
I'm not gonna use. It's just.
Hey, did you put the memory card in it?
Yes.
Yes. Okay. Good.
I have that on my list.
To put the memory card in.
Yeah, you look fit now.
That's all I had on the to-do list here, or the recording checklist is start the recording.
Yeah, can I say something?
No,
okay.
I'm kidding. Go.
Okay.
I just want to say a week has passed since the last podcast. And what happened since then? Anything you guys want to talk about?
Nothing comes to mind.
I think we might want to do this bi-weekly just to get enough content in between.
Yeah, of course. Yeah, we can't keep producing them at this rate.
No.
Because what should we talk about?
Exactly. So anyway, what's been on your mind lately, Lindblom?
Mine. Yeah, except for the moving to a new house. You mean more like development stuff. I've been...
Whatever you want to talk about, we'll talk about it.
Coffee.
No, I'm just thinking. Because we will fix this in post-production.
Yeah.
So we can cut it.
We'll edit this down.
Yeah.
It'll be a 4-minute podcast.
So we can think a little bit before going on. I mean, I've been down different lanes since the last episode. So there is a bunch.
You haven't been in an episode for like 1.5 years. So
yeah,
I don't think you need to reference the
one digital a week.
the last episode.
Won't it just be like one click away?
Yeah, but it'll still have publishing dates, I guess.
True.
But if we start a new channel,
yeah, we'll just make up a new name, make another one.
Yeah,
that's what people do on YouTube all the time. They change
Oscar and Christophers.
Hey, oh yeah.
What?
No.
You thought you weren't involved?
Yes.
Okay.
But I heard the S at the end. That was me. I was the S. Anyway, yeah. I mean, I've been doing YouTubing.
You have?
Yes.
How's that going?
Do we have the crickets?
No, but you started talking about Swift before.
Yes, I did. I didn't know if you wanted to talk about it. I really like Rust, but I like Swift now. That's what I started saying, that it was a long time ago. So I went into Rust and then I went out of Rust and now I'm into Swift. It's not that I don't like Rust. It's just that I started looking at iOS development. And the reason being that you got an iPhone. And a Mac.
Yeah.
M1, if I may. Anyway, I like coding. And I think most of us do. And we do one type of coding here at work. We do lots of types of coding. But the type of coding we do here is pretty complicated.
I use all the keys on my keyboard.
Yeah, but I mean, it's... What?
Yeah, just saying. I use all the keys.
I use one.
Yeah, but you also stole my keyboard. But we don't have to talk about that right now. Because I have your old favorite keyboard right now.
Yep.
That's weird.
It's an awesome keyboard.
The reason why I started looking at it now was that when I'm home, I want to do something simpler. So I was thinking, what can a solo developer do that is like something that you can play around with? And that was iOS development. So I started looking at Swift and it looks really nice.
Are you planning to become an app developer?
Only on the side. Like when I want to...
Everybody wants to be an app developer.
When I want to kick back and just code something,
right. That's
when I do it. When I want to do the serious web work, hard work.
Have you started building anything in Swift yet?
I just played around with it, like did an app, like add a button, click on it, see what happens, how does the UI changes and stuff. But yeah, I don't have any ideas.
Did the app involve a timestamp? You always have timestamps.
Yeah, I know. I just think, of course. I was just thinking, what did I do? I clicked the button, and to see that actually something happened, I of course put out a timestamp in a label. That's what you do, because otherwise it's not.
It's not a true app.
No. Yeah. Because how will you prove that you actually did something? It could be canned responses.
Right.
To the events. Yeah, but that's why I went into Swift, and I really like Swift now.
What do you like about it?
How it looks, how it is to type. It's nice. And it also reminds me of Rust, which I like too. And they are very, very alike. Swift is a little bit easier and Rust is a little bit safer. But they feel it's like you have structs and you do you do stuff with them. Yeah, that's probably something that we can cut out because it didn't sound good.
Lamest answer ever.
Yeah.
Badass developer.
Yeah. Okay, so you just like how Swift looks.
Yeah, I don't know. I mean, I just
You told me it was cross-platform these days.
Yes,
It's
it is.
compiler for basically everything.
yes,
So would you choose Swift over, let's say, .NET
yes.
if you were doing?
If I could, if the ecosystem was there, like if
that-
all the libraries were there,
Okay.
I would.
All right.
But I would probably choose Rust over Swift.
Right.
For the safety.
But Swift, in terms of structure, what is it in the syntax that makes it different from something like C#?
I mean, you can have labels on parameters if you want in C#. You can type which parameter, the name of it. In Swift, you can give them labels, but you can also have an internal label. So you can say sort by : and write it. And on the other side, you don't use by because it doesn't maybe make sense on the other side. So you can name it something else inside the function. So you get a very nice looking code.
Yeah.
They talk much about code language being a UI for the programmer. So, and that's what they are focusing on to make that.
But I can relate to that. I've had those. It's not common, but it has happened to me. It's like, I would really like to name this way in my function or in my method, but it wouldn't make sense to someone calling this method. So I'm going to name it as such that it makes sense to whoever calls the method.
Yeah, that's
because I'm always thinking about the, as you said, UI. I have always regarded API development in principle the same thing as designing any sort of UI, because that's what it is.
Yeah,
you have to be a good UI developer in order to create a good API.
Yeah, and in C#, when you have to make a decision, a trade-off, you usually trade off the internal. Like, I can live with the name inside the function being a little bit weird, but I don't want that name to leak out because it's very important that the caller of the function understands it easily.
Yeah, that's the most important.
So you don't have to, and in Swift you can decide, I want to have the same name, I want to have no name, like in C#, or I want to have a different name. So that's one of the things. And also they are...
you could, of course, just create a local variable inside the method.
Yeah, that's true. If I want to do that.
Yeah.
So that's one of the things. And it's also immutable per default. So if you want mutability, you opt in. And it also pass by value and copy on write. So
those two kind of goes...
Yeah, otherwise it becomes really slow.
But you should, like, once you start copying values, and you have mutability, you're in for a shit show, essentially. Because people are going to get confused. They think they pass a reference and they change it.
Yeah, no, but you can't in Swift. You can send by reference.
Yeah.
But then you have to put the ampersand in front of the parameter,
exactly.
and you have to mark that as an input in out.
Yeah.
So you have to do both. So you can't go around like in C#. You can put out on it that you are going to mutate it, but it's not enforcing.
Yeah, exactly.
You to do that. So you have to be. So it's also safer. Then, and I like that, as I have already.
That sounds.
And it's also really top down, and it's interpreted and it runs. They don't really use this as much, but you can change. I can't explain it, but it's like Erlang, I guess, where you can write to it and change the world as it runs.
Okay.
Yeah, I can't explain that. So cut it out.
Okay. Right. Yeah. So is it interpreted or is it bytecode or is it?
It's compiled to binary.
Binary, okay.
Yeah, it's LLVM. So it's on top. It compiles to LLVM instructions or whatever it's called, but they're intermediate language, and then it's compiled down to. So it runs on pretty much every.
Okay, so they use the LLVM compiler to get the binary at the
end.
The binary is what you're shipping.
Yes, it's the same as Rust. Rust also builds on top of LLVM.
Right.
And then you also get the optimizations from LLVM.
Yeah. So it's kind of like the first C++ compiler used to compile to C that compiled to binary.
Yeah, and then C++ went to Clang, which is on LLVM. So C++ is also using LLVM. So it's the same.
There you go, yeah.
And it's very interoperable with C and C++ and Objective-C, of course.
Right. So I think it's interesting. I mean, all the languages are today, just the fact that they compile down to the same bytecode and is just proving the point that all languages is all the same concepts. It's just different syntax.
Or UI.
Yeah,
if you
exactly.
like.
And so there's very little feature differences. Rust may be sticking out a little bit still in the way that it can enforce things, or the compiler enforces things.
Yeah, the borrowing thing in Rust is really
Yeah.
nice because you know that I have this, no one else can have it.
Yeah, exactly. But in the end, it's the same concepts in all languages. Basically, I think that's something for anyone who's learning programming or teaching programming. It's a lot of times you learn one language and you don't really get down to the concepts. Like you can see web developers doing something in JavaScript or whatever, not realizing how that would translate into other languages. Which, if you went more, I'm not saying learn programming from a theoretical aspect, because that's what you do. You like, if you, let's say you're studying computer science or something, you learn and you really go deep into the theoretical concepts first, and then you apply that through different languages. But I think it could be a good tool if you're learning programming from a practical perspective, to actually understand the concepts more upfront might actually speed things up a little bit.
I like to do it like both, like do this practical coding thing. Now I'm talking about new languages. And then I also read a book about it, or like the book about it. I try to find the book and then read it because it makes more sense when you like when you code and you see stuff. It's like, oh, how that work? And then you read about it, and you don't just think that you know how it works. You will know how it works and why it is. And also when I read about, as I said, I read the Rust book. I also read it Go over Christmas. But I think you become a better, or at least I think I have become a better C# programmer because of reading the Rust book, because it's still the same thing. You still have references to objects, and you still have async programming. And even though the C# compiler does not enforce you, but the things that Rust is preventing you from doing because it won't compile your code, it's probably something you shouldn't do even if you code in C#. You should think about that. And if you have coded a little bit of Rust, it comes pretty fast to you because you have been fighting with this borrow checker. So you know that I wouldn't be able to do this in Rust. So when you see it in C#, you might do it some different way.
That's all. Like, that's been the progress ever since, like, people were coding in assembly. Is that like the biggest change between coding 40 years ago versus today is like, you can't do whatever you want. The compiler won't let you. The compiler won't let you shoot yourself in the foot. Like,
we have C for that.
Yeah.
If you want to do that.
Yeah, but it's one like, it's a lot of, like Uncle Bob talked about imposed discipline when he talked about like, different paradigms that we sort of have invented, like object-oriented programming just prevents you from doing a lot of shit that you could have done before. And now it's like, we choose to put these restraints on ourselves so that things just get, simpler and more sort of like coherent, understandable. And it's like Rust taking the next step, and it's probably going to be something coming after Rust, which is even more locked down in terms of like, because you sort of like code these concepts into the compiler,
or where you have to just be more explicit. It's like, if you want to do, you can do most of the things, but you have to, or you can do everything. You just have to unlock those.
Yeah, exactly. And that's I think that is something that you want to. The problem here is Swift is interesting in the fact that Swift has been enforced on a lot of people, like anybody who works on iOS development, for example. It's basically
unless you want to use Objective-C.
Yeah, but that's like, yeah, I don't think anybody would choose Objective-C over Swift. Of course, you could do Xamarin, but that is equally...
Yeah, or Flutter.
Yeah. But anyways, like, it's interesting is that they can enforce good defaults, which feel like a problem at first. Like, if you're a new programmer, or if you're a programmer going into a new language and you're like, why can't I do this? Why can't I do that? Whatever, do I have to, put an ampersand on my, just to pass by reference? Like I've always passed by reference. Why do I need to put ampersands everywhere? And then you realize, okay, maybe it's not a good idea because due to mutability and thread safe code. And the problem is, I think for a lot of languages, looking at some of the more popular languages, they've had to pick defaults based on what would be easily picked up by the community. Like, there's a reason PHP became popular because it was so easy to pick up. And, the creator of PHP was really focused on, not breaking people's code. So they couldn't really change. Any mistake that was in like PHP 1 was still there in PHP 5, because they wanted to not break people's websites. And that is one of the keys to making the language popular. If you look at C#, we still have problems in C#, or we have, when they made C# initially, they were thinking about, they were targeting people who were writing Visual Basic. How can we make Visual Basic programmers jump to a somewhat more modern or more structured language? And so they had to add things, or they had to construct the language in a way to ease that transition. If they had created Swift 20 years ago when they created C#, it would have not been picked up.
But Swift may be a bad example when you're talking about
yeah,
it.
but
Maybe Rust is a better example because Swift was also designed to be very approachable, and you can just learn it as you. It's more like JavaScript or Python.
Yeah, but it's approachable, but that's sort of like relative to what, So imagine being a Visual Basic developer and then seeing Swift 20 years ago versus what they did in C#.
I mean, I look at Swift in my head right now.
Yeah.
It's very, very clean. It's like print and then hello world. That's all. And then you have your console. So it's like, and if you want to make a variable, you just say var equals something, and then it's there, or let, depending on.
Yeah, but there you've introduced a concept which is completely nonsensical to someone who's been writing a Visual Basic. Like, immutability doesn't even exist. Everything is mutable. Everything's a reference. Everything is,
Yeah, I'm just thinking that it's simpler, even simpler. Maybe it's too simple.
It's simple based on that you have the knowledge. And that's the thing. It's like functional programming is simpler than non-functional programming, assuming that you know the concept. But if you don't, then it doesn't make any sense. So, coming from that perspective, C# was designed in a way to allow for an easy transition away from Visual Basic. And that put constraints on what they could and couldn't do. And of course, there's been development ever since. Like we're talking 20 years ago, there was there were things that weren't even invented then. There were like the idea of dependency injection, but nobody's really done it in a constructive way, or it wasn't like hadn't take off. We're still writing SQL queries in your code and shipping them to the database and hoping that you get a result back. ORMs wasn't even a thing.
Yeah, not even Mongo was a thing. So we didn't have web scale.
Exactly.
Web scale was still not invented.
Exactly. So yeah, but it's interesting. Like every language built upon each other, but it's also a lot of languages, and that's what I'm saying. Like Swift is interesting in the way that they could probably have taken. Now, some of these concepts are becoming mainstream. People are starting to wake up to the fact that immutability is a good thing because we have like. How many cores did you have in your processor back in 99?
99. That I think it's Pentium 3.
I can't remember, but it was like multi-threading was not a thing. Like you didn't gain anything from that. So why make a language that would be that would be sort of lending itself to become thread safe? Because then you get away with things like the cost for that is to make everything immutable by default. But now it's a completely different environments. Like every computer has at least 4 cores, probably more, and building threaded applications is the only way of making an application faster, because we're not getting higher clock frequencies. We haven't been gaining clock frequencies for the past 10 years. We're only getting more and more cores. That's the only way of improving the performance of your application. And that's probably how you would see language moving forward as well. It's like imagine a future where Azure's been starting to do this with or Microsoft's been starting to do this with games. What is it?
I was going to do when you said imagine. I wanted to do this, ripple sound effect, so we could imagine stuff.
Okay, right.
Yeah, but
no, but I mean, Azure's been starting to offload games. Like some games partially execute in the cloud. Like they offload parts of your game. Remember when the latest SimCity came, and everything in the simulation ran on
SimCity 2000.
it was not 2000. It was
okay. Yeah, but that
the new
was
one.
the last one
The
for
new
me.
one that didn't take off. But all of the simulation ran in the cloud, and you just had a client on your machine. And then they had to rewrite it because people wanted to play offline, so they had to take all the code that was written in Java and port it to C++ and make it run on your machine. But so it's like in the future, today we're trying to create languages that makes it easy to scale out in terms of threads. Like functional programming is great at this. It's like you're just telling the computer what to do and not how to do it, because the computer has to figure that out itself. And imagine, in the future, your application might be running on hundreds of different machines all across the globe. And that's how you scale out, And you probably want languages then that makes it completely transparent. Or it's like, because today you have to, if you do microservices, you're still pretty much down to like, okay, I'm going to send this message now to that machine over there and then wait for the response.
But there is a gist from Chris Lattner, who created Swift, about the concurrency model for Swift. It's not defined yet, and he looked at actors and also not just stuck in one process. So what you're talking about is already something like they are looking at. Maybe that could be the concurrency model for Swift, the native one.
Yeah.
But I mean, local for the process. It's not really a problem. I mean, C# does that really good too with its thread pool combined with the task thing. I don't know what it's called, but the async setup. And also, I mean, other languages have it too. So I think the problem is pretty much solved there if we just make the humans not fuck it up.
Yeah. We'll beep that out. Yeah, humans are the major problem when it comes to...
Yeah, Oscar is also here in the room.
Yeah.
Hello.
Do you have any questions?
Can we go back to 15 minutes ago where I didn't understand?
Yes.
15 minutes?
No, I'm kidding.
No, well, we can clarify for anyone.
I think it was more like 20 minutes when he lost
maybe
when we lost
28.
Oscar.
I lost power.
Anyway,
I lost connection.
Yeah, this is interesting because now we have the opportunity to explain what the hell we just said to Oscar. What do you wonder? What do you...
We can start about when Lindblom explained good things about Swift immutability, and he talked about the
in out.
Yeah,
you mark the parameter. Yeah, in C# you can like say out, and that means that you will modify whatever you send in, and you can actually set that to reference parameters also, but you usually don't because you don't have to do that.
First things first. Do you know what the difference is between passing by reference and passing or copying a value?
I think I do, but I might not.
I have another question. Do you know that there are reference types and value types in C#?
Yes.
Yes.
Because
what's the difference between them?
Yeah, so that's
this is an oral exam.
Yes. If you miss this, you might get fired, but don't feel any pressure.
Reference types are just pointing to somewhere else, and basically what they point to, if that changes, the reference changes as well, if I'm not mistaken.
I mean, you're kind of right. It's just that if that changed, the reference does not change because it still references the same piece of memory. It's just that memory changed. But yes, you're correct.
Yeah, so it's the reference changes with the change, right?
No, the data that the reference is pointing to changed, but the reference is still the same unless you point it to some other object. But anyway, so
there is a practical part to it and sort of like a theoretical part to it, or I don't know, but because it's built into the language, like a reference type and a value type, it doesn't really because in the end, all we're having is a memory address, right?
Yes.
So imagine like you have this let's say I had a warehouse, and all the shelves are marked with some number, and the reference type it actually consists of sort of two things, because first you have the reference, which is kind of like a piece of paper with
a memory address.
Yeah, with the number of the shelf where the stuff is.
Sure.
But a value type is like, it cannot be put on the shelf. You have to like keep it in your hand, right? So if you are a function and Lindblom is a function, and you tell Lindblom to go do something, like take this coffee cup and drink it,
All right.
If the coffee cup is a value type, you would hand him the coffee cup, right? And now it's his coffee cup.
But that's not what happens in C#.
No, I know.
Yeah, I'm just saying, so we don't. I get confused.
Stop.
But then you stop. No, I'm kidding. But okay.
Right. But if the coffee cup was a reference type, you wouldn't actually hand him the coffee cup, but you would hand him the piece of paper.
It points to where the coffee cup is.
Yes. Now, here's the thing. In both of these cases, the analogy doesn't actually work, because you always copy whatever it is that you have in your hand to Lindblom in sort of like the normal scenario, right? So you actually, when you give him, if you have a value type and you're giving him the coffee cup, you're actually copying your coffee cup. You're making an exact replica of your coffee cup, and you're giving him that replica, right? So now you both have each one's coffee cup. Now he goes and drinks the coffee cup, but you still have coffee in your cup because you have different coffee cups.
So I can send a value to a function and then change the value and function.
And in a reference type, it's exactly the same thing. But what you're having in your hand is the reference and not the coffee cup itself.
Exactly.
So you are copying your reference, the piece of paper with the address of the shelf where the coffee cup sits. You copying that paper, you're handing Lindblom the paper, and now Lindblom looks at the paper and says, I'm going to go and drink this coffee cup. He goes out into the warehouse, drinks the coffee cups, comes back, tells you, I've drank the coffee cup. You take your reference, which you hopefully hasn't changed. You go back into the warehouse and you see, the coffee cup is now empty.
I want to change this story a little bit because I think we can get another concept in
but
here.
I understand it.
No, stop. You shouldn't understand his. You should understand my. You should understand my story.
Okay.
You hand me the address of the coffee cup, so I look at my note, and I be like, "It's a race," and now we have a race condition because I run and you run, and we both want the coffee.
And let's see, I say
win.
after I give you the reference, I want to drink it too.
Yeah, exactly. Or you tell both of us to go drink the coffee. Like you're passing the reference, the same reference to both of us. Now Lindblom and me are going to chase down into the warehouse and drink the coffee cup.
Yeah.
I am obviously faster, right? So I go there, drink the coffee.
Saw you. You were so agile when you picked up the thing from the floor.
Exactly. Now Lindblom comes right after, and then exception. There is no coffee in the coffee cup.
I have the perfect. I will improve your example even more.
All right.
You and me, we order coffee from Mr. Oscar at the same time. So we I want coffee. And then he just makes one and he sends it back. Coffee done. Boom. Address. And then we have the race condition and then we blow up. Because we both think we got true back from you. It's like coffee is made. I'm going to use the coffee.
We got the coffee reference.
Yeah, we got the coffee reference of which we think we checked like...
This is so actually realistic that it's insane.
We checked this. If coffee, not null. Like my reference is not pointing to null. I know that.
Yep.
And you know that.
Yep.
I'm using my coffee and you use your coffee.
Yep.
And now, as you said, exception.
Buffer overrun.
Yeah.
I'm not a barista.
Null reference.
Yeah.
Something. Yeah. So that's a race condition.
Yeah. You can't make my reference a null
But we
reference.
have to drink the coffee. So now it's empty.
Yeah. All I have a reference to
took
is
it.
an empty coffee cup.
Yeah. I put null there /0
Inside of the coffee cup.
Yeah,
Right.
in your.
Yeah, because
in
if
your
you
reference,
took your reference and said
that's
now
true.
my reference is null, you just changed the reference.
Yeah.
So now I have my own
You're
coffee
correct.
cup. Yes.
I did not dereference
Exactly.
your reference, but I could delete the memory, and you would have a dangling pointer on your hands, and it could be anything. It could be something you didn't want in that place.
Yeah. We're going too deep. Okay, next question.
No, but I want to continue on the reference.
All right.
But knowing this, that you guys told me now about what is a reference versus a value, basically, or whatever you call the other part of it, passed by value or passed by reference, right?
Mhm.
Yeah.
How, like, to put it in more concrete
We
examples?
actually didn't answer his
Yeah, we
question.
did the out. We never talked about out.
Yeah.
Yeah.
Yeah, that's why I'm still confused.
Right. So going back to handing over the coffee, I said you're always copying whatever you have in your hand.
Yes.
Now, with the out parameter, which we have in C# too, by the way, but that's more like a return. It's
Yeah,
ref,
but that's-
ref is
I've
more.
seen it.
Yeah,
That's why.
ref. Yeah, ref.
Yeah, you have the ref
Yeah.
keyword.
I was meaning ref, but I
Yeah.
think you can do out.
Out is a return value.
Yeah, but you can
Sort
say
of
like
ish.
this, like
Yeah,
you
it's
do
true,
new,
it's true.
so you send
It's
in
actually,
this.
yeah, I'm handing you my reference and you
Yeah.
can put whatever you want in
Out.
that.
I should have said ref, that you should have put the ref when you mean a reference value. But never mind.
Let's say you have a value type. Okay, we start with ref, right? Let's say you have a value type. The coffee cup is a value type. Now, you want Lindblom to actually mutate your coffee cup. You want him to drink the coffee. And you
Not
want
just take a copy of
exactly.
my copy.
You don't care about how much coffee he has in his body, but you care how much coffee you have in your cup. You know, so you want to hand him the coffee cup and have him drink it, but it's a value type. What do? Right? You can pass by reference. So there is this keyword in C#. You put ref. Actually, he puts it in his method signature, but whatever. And now you're putting your value type inside of a reference and then passing the reference. So he gets a reference to your value,
Right.
basically, in a way. And now he can drink.
So nothing is
So he-
copied, basically.
Exactly. And this could be used also for memory optimization, because if you're processing a lot of data and you're having value types, you might be starting to use
Too much
memory,
space.
because the other way of not, if you don't pass by reference, you would have copy the coffee cup,
Every time.
hand it over to him, and he will copy the coffee cup and hand it back to you, like a return value from the method, right?
Oh,
And now everybody has a lot of coffee cups, but you only care about one. The thing though is with value types, in the way that it's managed in memory in C#, is that they're very short-lived because you never put it on the heap. So you generally don't run into memory issues because you clean up the memory so fast. But it could become a problem if you're having a function that does a lot of work, and all of a sudden you sit with 1 million coffee cups on your lap, and
right.
that could become a problem. So then you can pass by reference. Now there is another keyword called out.
But just
Okay.
pause one sec. So when you guys say pass by reference, do you mean both the cases where you have a value type that you pass by reference, but also when you have a reference to begin with? Or is it always using it on value types?
I think it depends on the context and the language and
Okay.
everything else around it when we're talking about it. It's usually kind of obvious. From
Yeah, when I talk about passing by reference, I just mean the action of sending something by reference.
So it doesn't
Like,
have to
you
mean
send
that
me an
it
address.
was a value to begin with.
You send me an address, then you sent me by reference.
Yeah, sure.
Now there is another keyword in C#, which is called out, which is actually in a way the opposite of ref, because in ref you're using when you're passing a value type, but you want to pass it as a reference. You can pass a reference as a reference too. It doesn't matter. Like, 'cause
But
the
that
reference
makes
is-
no sense.
Yeah, it's kinda-
it's
it's
just
pointless,
to,
right?
No. If you
no,
want
yeah.
to show,
Then he can mutate your reference to point it to a different address.
Oh, okay.
And then
yeah, but I can also you can expect me to do something with it. So it's more like that I would probably do something with your data. Otherwise, I wouldn't.
Yeah,
ask
but
you
this is what we'll come back to that when we talk about the difference in, let's say, Swift versus C# and how that semantically means the different things. I just briefly want to touch on the out parameter, or the out keyword. Is basically when you have a method which has a parameter which is prefixed with out, it means that you're handing him a reference and say, fill this up with something. And then he sets that reference, and now your reference points to whatever he set it to. And so out makes sense.
Is that
when
the
you're
out
passing
you
a
see in
reference.
the arguments inside the parameters?
Yes.
Okay.
It's like usually these try methods have these.
Yeah.
So you do
Yeah.
try parse or something like that.
And then you send something in and you say out,
Yeah.
blah.
So you get
Yeah.
true and a value if it succeeded.
Yeah.
Otherwise, you just get false. And
Right.
Now, the thing is that in C#, almost everything is a reference type. Anything that inherits or anything that is a class is a reference type. Like class equals reference type in C#.
Yeah, and strings and arrays.
Are also references.
But string is a class.
Yeah,
right? But everything that is a struct is basically a value type. It's like an integer or just character is a value type. Yeah. Since like 99% of all the data you touch in C#, as soon as you start to like working with objects or reference types, almost any time you call a method, there's got to be some reference passing going on. And this is where it can become a problem if you're working in a multi-threaded application and you're not really careful and all you're doing all day is just passing references around. It's really, really easy to run into race conditions.
Because you've sent the reference to multiple places at once.
Yeah, exactly. And maybe, you pass a reference to Lindblom and he passes it to someone else. And then all of a sudden, maybe you are not, you call Lindblom in the context of the same thread, but you don't know what he's going to do with it,
Right.
So he might doing something like...
Yeah, you might have done
Lindblom might be a rogue third-party library that you don't know what it's doing. And that's when shit can hit the fan.
Right.
Yeah. But I mean, because you can have you might have made checks or set the object up beforehand, and then you think it's unchanged because you just checked this. But if you did like an async call or something, so you left someone else to run some stuff on your thread, or you have that reference in some other thread, someone else might change it.
Without me seeing any...
Yeah, in between your lines of code that you see execute.
Now, here is the first issue then. If you want to talk about C# and how it was designed, what you might rather have, and they actually have this in C#8, I think. You can define... I think when you create a class, you can say that it's going to be immutable. You don't have to actually... No, they have a new keyword where you can create an immutable class. Look it up. I can't remember the name of it.
Yeah,
now.
I tried to remember it too.
Yeah, but they have this in the language now. You can create a class and say this is an immutable object. And that's perfect for DTOs and stuff like that.
Yeah,
DTOs is data transfer object. It's just objects that you're passing around with data. Because you usually want to pass by reference because it's more efficient, right? You're just passing a piece of paper.
You don't copy.
Exactly. You don't have to... imagine having a big object or an object graph. You don't want to do a deep copy and handing that over to Lindblom just so he could do some processing.
I just want to point him to it.
Exactly. And so that's what you want to do. But in C#, up until C#8 or whatever it is, the way of making this thread safe is to create immutable objects then. That's a lot of work because that's not the default of the language. So you have to make sure your properties cannot be set. The only way of mutating it is actually creating a copy of it with different data. Datetime object is like this in C#. It's an immutable reference type, if I remember correctly. You can't change the value of a datetime, but you can pass it as a reference. Every time you change it, you get a new datetime.
So it's only to make sure that it will not change unintentionally.
Yeah. So anyone who wants a different datetime creates it. Yeah.
Okay.
So you go, datetime
now
XYZ. Oh yeah, datetime.now.add today. Add days 2, and you get a new datetime which is 2 days ahead of the whatever now is.
But then it can't be changed.
No, if I remember correctly.
All right.
But that's basically how all immutable types works, and this helps tremendously with just avoiding any kind of threading issues because this is the most common issue. Now, another thing, and this is where we come into, I think, the semantic difference between C# and Swift and other languages is in C#, whether you're passing a value or a reference is implicit. So I'm handing over just some variable, right? If that happened to be a value type, it's going to be copied and sent over to the other method.
Right.
And if it happened to be a reference type, it's going to be passed by reference. And this is also something that could be, if you're not careful, you might make assumptions, and it's not obvious from the code. So some languages, they say, well, we always pass by value. Like we always copy the value and hand it over to the other method. That by itself, like even then, if you're passing a mutable object, it doesn't matter because you're getting a copy anyway. So whatever you do with your object, it doesn't matter to my object because you have a copy, right? And then if you do want to pass by reference, you add something, to the signature or on the calling side or whatever. So it
That's
becomes
what you were talking about, right?
exactly that's the ampersand.
in out
Yeah.
and ampersand.
So
in
that,
Swift.
and then it becomes really obvious. Like imagine reading the code in some context of, maybe you don't have an IDE or something that can tell you that it is a reference type. You know immediately that, this is passed by reference.
Only by looking at it.
Exactly. And that means, in the context of this method, whatever I'm doing, I'm also changing the object that the other guy was having.
But okay, so in C#, it's implicit, so you can't see.
You can see it by knowing what type it is, but then you have to like go up the
But
inheritance
then you have to
change.
inspect it in some way.
Yeah, exactly.
Yeah, but also you would, since we always do it, we don't know who will mutate this, because in Swift you don't, or in Rust, like languages that support this, you don't ask for that unless you're going to do something with it.
Right.
Yeah, so
Because
it's a
that's
very
the
good
thing.
way of like putting up a sign like, hey, whatever you put in here, I'm gonna start fiddling with it.
Yeah, but I mean, let's say if you're a JavaScript developer, use let and const. Like if you're not mutating something, make it a const. Make that, because that's not. It doesn't make any difference after Webpack is done with it, because then everything is var anyway. If you set it like low browser support enough, but you still signals to the next developer or to yourself that this is not going to change. This is just some variable or a constant that I...
Until you put a mutable object inside of a const, and then you fuck it anyway. Because it's the reference. It's a constant.
That's the thing.
I know
but
that.
I mean, then you like, this will at least not change to a different object. It will still be this.
Yeah.
But in Swift, everything is a deep copy. So if you send an array, that's deep. It's also a value object.
Yeah.
And dictionaries. So if you only read, they don't copy the value. They don't it doesn't take up any new space in memory. It's still the same memory.
Okay, so they do that like an
Copy on write.
optimization.
If
Yeah,
you do,
exactly.
if you change something in it,
Right.
then they copy the whole thing.
Right. So when the compiler compiles the code, it checks whether the method that you're handing the object to, will it do any change to it? If it doesn't, then the compiler actually passes it as a reference, because nothing's going to happen anyway.
But when you wrote it, it was passed as a value.
Yeah, it
exactly.
looks like that, because that's how the program works. So you
Yeah.
can expect it to work as if it's always your own value.
Yeah.
You can
But
do
you
whatever.
you don't run into the memory issues of having to copy everything all the time. And it's also, of course, requiring CPU time as well.
Which compiler are we
Yeah.
talking about here, or which language?
Swift.
That's Swift. Yeah.
Okay.
But there are other languages doing the same thing. Yeah.
All right. I think I got a case of the pass by reference when I was in JavaScript today, because I made a method that returned a string with some variables in the string. So it was with the backticks. I can't remember the name of those strings where you can...
I think they're called templates.
Yeah.
Aren't they?
Yeah, template strings, right?
Yeah.
Yeah. And I passed the method into, like, with the view syntax with the double squirrely brackets, like into the HTML. I passed it in without the parentheses, and it just printed the function. And then I passed in the function with the parentheses, and it printed the result.
Yeah, you didn't call the function.
I passed.
You printed the function.
You printed the function.
Yeah,
I
because you
literally
can do a
passed-
function to string in JavaScript, and then you get the code for a function.
That's an interesting aspect of JavaScript, and it's kind of like it comes from the in a way it comes from the functional nature of JavaScript, because functions inside of JavaScript are objects.
Yeah, I've heard that.
So you can even apply. You can actually add properties to the function. Like a function in JavaScript, since it is an object, you can actually add properties to it. So it can be a function which carries data, which is a bit of a mind-boggling if you're not like aware of what a function is. But that's just one of the cool aspects of JavaScript and why I like it. Because you can do crazy stuff in that language.
But isn't like everything an object in JavaScript?
Yeah, pretty much.
Yeah.
So it's fun.
Yeah, utterly unsafe.
Yeah. It's prone for disaster.
Yeah. And then you have the whole prototype
Prototype
thing.
object.
So that is
that's
that's like reference on crack, where you have where they like the
you have the prototype chain.
exactly.
I haven't really understood what the purpose is.
Purpose is used to fuck with people, I guess. But
I mean, it's a type of inheritance in functional inheritance, I guess.
but it's like
without classes.
it's like inheritance with value. That's the weird thing part. Like, and since you can change anything, there's no classes, there's no structure. Everything's just an object with properties or a function. So maybe I have Oscar, and I'm gonna make a Lindblom from Oscar. Now you are the prototype of Lindblom. So and now I change Oscar. Now I changed you.
Yeah.
Like that's
that's how it works. I mean, let's say I have a name function, and it's Christopher, of course. And then Christopher creates a new object and set me to the prototype of you, Oscar. And he asks you, what's your name? And then you don't have it, but I have it. So it will get my name function because I'm the prototype.
Oh,
and
so
if I don't have it,
the
then my
abstract class.
prototype will be checked for that function. So if you want to have something, you put it deeper down. But if you want, you can just shadow my implementation with your own name implementation.
yeah. So
It's like a Wild West.
every sort of layer in the prototype chain,
Are there many layers?
you can have as many you want.
Yeah.
You can have a prototype of a prototype of a prototype, basically. Every object has a prototype all the way back to the sort of root object.
Yeah, I think you can get to null. I mean, if you do like, what is it, like object.define, and then you send in an empty object, and then I think the second parameter is the prototype.
Right.
So you can set it to null, because if you do just these curly braces to create your own object, you actually have a prototype. So you already have some function on it. And that's from that prototype.
Okay.
Which is the root one. But if you want a cleaner one,
you can create an even cleaner one. Okay,
yeah. There is a cleaner one. It's where you set the prototype to null.
Interesting. Yeah, but it's such a super simple concept. It's of course a dangerous concept if you're not like taking care.
They also have this, which is fun. It's like, this is always the object, unless you do bind or apply or something else and redirect it.
Yeah, but it's the problem people have with prototypes is that they think JavaScript is an object-oriented language when it kind of isn't. So you think you have a class, like because it even has a new keyword, right? You can go new X, Y, Z, and people think that now I have a new object of this class, and then someone comes and changes the prototype, and you're like, what? What did just happen?
The thing that new does is create this context for that object.
Yeah.
Can we say my eyes?
No.
No, we can. I think we're done. I think we're done with today's deep language discussion.
Yeah, very deep.
Very deep.
Like this deep.
Yeah, it wasn't too deep though, but it was a good talk. Until next time, see ya.